Hello. Yeah, Priyanka, am I audible? Priyanka, Pallavi, am I audible to you? Okay, so today we are going to start with the chapter probability. Pallavi, can you switch on your mic? Pallavi, Priyanka, Pallavi, Nagashri, can you switch on your mic? Anybody? Chalo well. Probability is, it is an like uncertainty you are judging. All right. So first of all, let us understand the things which we generally use in probability. So we use a coin. You are totally aware of it is having one side head and one side tail. Then we use a dice generally for which we are calculating probability. And it is having six faces marked with 1, 2, 3, 4, 5, and 6. All right. Then generally we see questions regarding weather forecasting. Got it? And what terms do we use there? It's a sunny day. Or it's partly cloudy, means little sun and little cloud. It's cloudy. It's raining there. It's sun and rain. It's windy, means some high wind is blowing. And it's totally clear sky. Got it? So these are the terms like what is the probability that the day is cloudy, that the day may have rains. And generally we use in like cricket matches. So they generally looking at the previous data of yesteryears, and then they calculate that it's a sunny day, it's a rainy day, it may be it may be an hour where it will be raining. Then we have playing cards. Now, first of all, we'll understand what different kind of cards do we have. So here in playing cards, we have four suits. Like this is a suit. This is what we call spade. This is heart. This is diamond. And this is club. Now each suit, and there are four suits. Now each suit has 13 cards numbered from 2 to 10. Then jack, this is jack. Then queen, king, and this is ace, A. So each suit has 13 cards. Now there are three face cards. Every face cards. Face cards are what? On which face is there. Am I correct? Face card is what? On which face is there. Yes. Now there are 16 honor cards. 16 honor cards. Honor cards include 12 face cards and 4 aces. All right. These are called 13 denominations. 13 denominations. Every suit has 13 denominations: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, then jack, then queen, and then king. All right. I hope everybody is clear about the cards. Now, there is a term you will like understand and you will see very frequently: random experiment. Got it? So there will be a term you will see very frequently, that is random experiment. Now, what is random experiment? So there we will understand few terms: random experiment, sample space, event, and difference between experiment and event. These are only theoretical points. You just don't have to write them. You just listen them carefully. Okay, so what is a random experiment? Random experiment is what all that are the possible results. Getting my point? So, like if you like toss a coin, you get head or tail. If you roll a dice, you get 1, 2, 3, 4, 5, 6. Got it? So possible results are 1, 2, 3, 4, 5, 6. So random experiment is an experiment which has more than one outcome or one result. So what is a random experiment? A random experiment that has more than one result. And it is not possible to predict the result in advance. Means there is always some uncertainty. Getting my point? Like if you have a double-headed coin, means a coin having heads on both the sides. So if you have a coin having heads on both the sides, so if you toss it, you will always get an head. So in that case, it's not a random experiment. So random experiment is what? It has more than one possible result and it is not possible to predict the result in advance. Am I clear? It is not possible to predict the result in advance. Got it? Now, what is outcome and sample space? See, the possible results of a random experiment are called outcome. A possible result of a random experiment is called outcome. So like if you roll a dice. So rolling a dice is what? Random experiment. In that experiment, outcome is what? It can be 1, it can be 2, it can be 3, 4, 5 or 6. Am I clear? So getting this 1, 2, 3, 4, 5, 6, these are called outcomes. And set of all these possible outcomes of a random experiment is called sample space associated with the outcome. So set of all possible outcomes of a random experiment is called the sample space associated with the experiment. Set of all possible outcomes of a random experiment. The set of all possible outcomes of a random experiment is called the sample space associated with the experiment. Got it? And what? There is a definition called sample point. So each outcome of a random experiment is called sample point. Priyanka, is that clear to you? No. See, all the cards are explained here, which I already told you. Just see a very simple question. It was there in 11th class NCERT. See, before starting the probability of class 12, it is very necessary that we revise that of 11th class NCERT. In each of the following, describe the sample space for the indicated experiment. Now, if a coin is tossed 3 times, what can be the sample space? See, initially, we can get in the first toss, we can get head or tail. Now, with respect to each one of it, again, you can get head or tail in the second toss. Again, with respect to each one of it, you can get head, tail, head, tail, head, tail, head, and tail. So, what are the possible outcomes? See, head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So these are the possible outcomes if you toss a coin 3 times or you toss 3 coins simultaneously. Got it? So these are the sample points and their collection is constituting a sample space. Am I clear? Now, another sample space, a dice is thrown 2 times. So if you throw a dice 2 times, what do you get? You get 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, or 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, or 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, or 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, or 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. So these will be the 36 sample points, or these 36 elements will constitute the sample space if a dice is thrown 2 times, or two dice are thrown simultaneously. Got it? Now, next is what? A coin is tossed and a dice is thrown. So if you toss a coin first, either you get head or you get tail. Then a dice is thrown. So after getting head, you may get 1, 2, 3, 4, 5, 6. Similarly, in tail, you may get 1, 2, 3, 4, 5, or 6. So what is the sample space? It is H1, H2, H3, H4, H5, H6, T1, T2, T5, and T6. Am I clear? Now, this is the sample space they are explaining for a pair of dice is thrown. Then this is the sample space they are explaining for a coin is tossed followed by a dice is rolled. Got it? Now, an experiment consists of tossing a coin and then throwing it second time if a head occurs. If the tail occurs on the first tossed, then a die is rolled once. Find the sample space. Now see, throwing it second time if head occurs. So if in the first throw you get a head, then you toss the coin again. If you get a tail, then you roll a dice. So what will be the sample space? H H H T. If head occur, you toss it again. You may get head, you may get tail. If tail occurs, you throw a coin. So T1, T2, T3, T4, T5, and T6. Got it? Now, see a simple question. An experiment consists of rolling a die and then tossing a coin if the number on the dice is even. If the number of dice is odd, the coin is tossed twice. Write the sample space. Okay, just think about it once. An experiment consists of rolling a die and then tossing a coin once if the number on the dice is even. See, first of all, you are rolling a dice. If you roll a dice, you may get 1, get 2, get 3, get 4, get 5, or you may get 6. Yes or no? Now, if an even number occurs, you toss a coin. Means if 2 occur, you toss a coin, you may get head or tail. Head or tail. Head or tail. Now, if the number on the die is odd, the coin is tossed twice. And if the number on the dice is odd, the coin is tossed twice. So now it will be head, 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 tail, tail, head, tail, tail. Similarly here, head, 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 tail, tail, head, tail, tail. And tail. So this is going to be your sample space. See, 2H, 2T, 4H, 4T, 6H, 6T. If one occur, then head, 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 tail, tail, head, tail, tail. 3 पे भी वही same. And on the 5 also, those 4 same. Am I clear? Suraj, is it clear to you? Suraj. Now, any subset of a sample space S is called event. Any subset of a sample space S is called event. For example, two coins are tossed. For example, two coins are tossed. So you may get a head, you may get a tail. So sample space is going to be what? Head, 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 tail, head, tail. Now there is an event that both are heads. So one event is favorable, that is HH. And this HH, it is a subset of the sample space. Am I clear? This HH, it is a subset of the sample space. Got it? Now, type of events. Now, what are different type of events do we see? Impossible event. Impossible event means occurrence probability is 0. It is very impossible. It is impossible for that event to occur. Like if you throw a coin, if you throw a dice and you say what is the probability of getting a number 7. So definitely it is an impossible event. Now there comes sure event. Sure event means it will definitely occur. So like if you again throw a dice and somebody says, what is the probability that, and somebody says, what is the probability that occurring number occurring is less than 8. So definitely the number which will occur will always be less than 8. Am I clear? So number is less than 8. So that's what we call sure event, and the possibility of their occurrence is 100%. Now there comes simple events. If an event has only one sample point of the sample space, is called simple event. Got it? Like if you see while throwing a dice, we can say that it is made up of 6 sample events. E1 or E2 or E3 getting 3, E4 is getting 4, E5 is getting 5, E6 is getting 6. So there are 6 sample events. So elementary event NS is P. That means if there are a P number of elements in the sample space, then there will be total number of P simple events. Got it? Now compound event. If an event has more than one sample point, it is called compound event. Like tossing a coin twice. So HH, HT, TH, TT you will get. This is what we are going to get. So each event has more than one sample point. So like number of tail is at least 1. So what it will be? HT, TH, TT. So that is a compound event. Now mutually exclusive events. So events are said to be mutually exclusive if one event does not let the other event occur. Getting my point? Two events E and F are called mutually exclusive events if the occurrence of any one of them excludes the occurrence of the other event. If they are not, if they cannot occur simultaneously. Like if you toss a coin, you get a head, then it won't let the tail appear. And if you get a tail, it won't let the head appear. Am I clear? Now, like if you throw a dice, E is the event of even number appear. F is the event that an odd number appears. So definitely this E and F. E is odd number appear, F is even number appear. So definitely this E and F, they are mutually exclusive. They cannot occur simultaneously. And in that case, E intersection F goes 5. We say E and F are disjoint sets. E and F are disjoint sets or mutually exclusive events. Got it? Now, exhaustive events. Guys, just go through it. I will be back in a moment. Am I audible? Pallavi, am I audible? Now we have just seen mutually exclusive events. Now exhaustive events. Exhaustive events is what? Unknown caller. Exhaustive events. Exhaustive event is like you throw a dice. You like define 3 or 4 events over the sample space. And there is no other event which can occur out of that sample space. Then we call them exhaustive events. Getting my point? Like E is what? A number less than 5 appears. A number less than 5 appears. So E may what do we get? 1, 2, 3, 4. F is what? A number greater than 3 but less than 5 appears. So F is what? 4. There is an event G, a number greater than 3 appears, means 4, 5, 6. So is there intersection? Is there intersection? Is total sample space? Yes. Then E, F and G are called exhaustive events. Even I can say E and G are in itself exhaustive events. Excluding F, E and G, they are exhaustive events. Got it? So E1, E2, E3, En, these are the sample space of S. If their intersection is sample space S, union, sorry, then E1 to En are called exhaustive events. Got it? If EI intersection EJ is phi, I is not equal to J means they are their pairwise, their intersection is phi, they do not have anything in common. Then in that case, events EI and EJ are pairwise disjoint. Now, if union of all of them is S, then E1, E2, E3, En are called mutually exclusive and exhaustive events. Got it? If they both occur simultaneously, then E1, E2, En are called mutually exclusive and exhaustive events. Now see a simple question. An experiment involved rolling a pair of dice and recording the number that comes up. Describe the following event. The sum is greater than 8, event A. Sum is greater than 8. A pair of dice they are rolling. So sum is greater than 8. In how many ways it can occur? Say you will get greater than 8 where sum is 9. 9 we can get how many ways? 5, 4, 4, 5, 6, 3 and 3, 6. Got it? So 4 ways. Now if sum is 10, there will be 5, 5, there will be 6, 4, there will be 4, 6. Now if we get 11, there will be two ways, 5, 6 and 6, 5. And if we get 12, there is only one way, 6, 6. So it is sum getting 9, 10, 11 or 12. Sum is greater than 8. So this is how it occurs. So see, B is 2 occurs on either dice. So if you want 2 on any one of the dice, then what will be the sample space? B. B will be what? This is A. Now B will be what? B will be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then 6, 2, 5, 2, 4, 2, 3, 2, 2, 2 already came and 1, 2. So it can occur in how many ways? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 ways. C is the sum is at least 7 and a multiple of 3. Sum is at least 7 and a multiple of 3. So sum can be 9 or sum can be 12. Sum is at least 7. So C is what? Sum can be 9 means 5, 4, 4, 5, 3, 6, 6, 3. That's it. Or it can be 12 to 12, it can be in 6, 6 ways. Now, which pair of these events are mutually exclusive? Now, mutually exclusive means their intersection should be 5. Definitely A and C have so many elements common. Now, if I talk about A and B, uh, A and B, their intersection is 5. Similarly, A and C intersection is also 5. So A and B are mutually exclusive and A and C are mutually exclusive. Got it? Hence A and B and C are mutually BC. Just a moment. Yes, BC. I have written wrong. BC. They are mutually exclusive because they do not have anything in common. Now, algebra of events. Now, this is also something theoretical. First of all, complementary event. Complementary event means not A. Got it? Like if you throw a dice, you say an event A is occurrence of 5 or 6. Then A complement means non-occurrence of 5 or 6. So A complement is what? Occurrence of 1 or 2 or 3 or 4. So A complement consists of all those elements which belongs to the sample space but which do not belong to A. Got it? So A complement is an event which belongs to sample space and which does not have anything common with A. Am I clear? Now, union of events we all know it is A union B. Intersection of event is what? A intersection B. And then A minus B. A minus B means all those elements which are in A but not in B. If I see it with a Venn diagram, this portion, this portion is your A minus B. Got it? This portion is A minus B. Now see, two dice are thrown Event A, B, C are as follows. A is getting an even number on the first dice. B is getting an odd number on the first dice. C is getting the sum of the numbers on the dice less than or equal to 5. So now it is very simple, getting an even number on the first dice. So on the first dice, even number can be 2 or 4 or 6. And on the another dice, it can be any number. So there will be total 18 entries. 6 3s are 80. Got it? B is the event odd number on the first dice. So one odd number can be 135. According to that, second dice can have 1 2 3 4 5 6. C is the event getting the sum of numbers on the first dice less than 5. Now it's very simple. You can calculate it. Getting the sum of the numbers on the first die less than 5. So sum 1 cannot be, 2 can be 1 1 on both, 3 can be 1 2 or 2 1, 4 can be 1 3 3 1 2 2, and similarly 5 and 6 we can calculate. Got it? Now let's go with a small summary finally. So what is the sample space? Set of all possible outcomes. Yes or no? Sample point elements of the sample space are called sample points. Event. A subset of the sample space is called an event. Impossible events. The empty set whose probability of whose occurrence is 0. Sure event. What? Entire sample space. Got it? Mutually exclusive events. A and B are mutually exclusive if their intersection is 5. Exhaustive and mutually exclusive events are exhaustive if their union is the sample space and they are pairwise disjoint. Complementary event or which is means not A or B means A union B, A and B means A intersection B, and A and not B means A minus B. Got it? Now in our next lecture, we will start with the probability which we generally use in class 12th. This was only the like some explanation about the class 11th probability. Am I clear? Now I would just like to ask for a small feedback.